Hey, this is Avi Gutman with another Ask Me Anything event brought to you by quantreasoning.com. I invite you to join me live next time. We do this every Saturday at 11 a.m. Eastern, and you can attend for free by starting your free trial at quantreasoning.com. Okay, so we have here a data sufficiency question with some interesting looking free info. The free info says that the square root of something is equal to the thing itself. And I wonder if maybe what is difficult for a lot of people here is the fact that the thing, I keep referring to it as the thing, it's a product of two unknowns, x times y. And I think it would be better to not think of it as the product of two unknowns, x times y, but rather just think of it as a thing. The square root of something is equal to the thing itself. And then just think about that for a while. I don't think it makes sense to read on. I wouldn't read on at that point. I would ask myself, when does that happen? Under what circumstances would the square root of something be equal to the thing itself? Certainly the square root of 10 is not the same as 10. I just used 10 as an example. So the square root of what kind of thing is the same as the thing itself?
Perfect square?
Okay, let's take a perfect square. 25. Is the square root of 25 the same as 25?
That's not
0 and 1.
Yeah, it seems like it's pretty rare that taking the square root of something wouldn't change it. And if it's useful to you, maybe try raising both sides of this equation to the power of 2. Because I think that for a lot of people, it's easier to think of something squared as opposed to a square root of something. So if I square both sides, what is it then saying? That xy, something, is the same as xy squared. So something doesn't change when you square it. What kind of number doesn't change when you square it?
0 and 1.
That's right. NG is correct.
-1, 1 and 0.
Well, I think negative
Means,
1 does change when you square it. But -1 squared is not -1. -1 squared is +1. My advice is to not think about x separately and y separately, although we might do that later. But for now, when you're just analyzing the free info, don't think of them as two separate unknowns, because the free info isn't about x or about y, it's about the product, xy. So let's just think of it as something. Some number, some place on the number line, some tick mark called xy, doesn't change when you square it, or doesn't change when you square root it, however way you want to think about it. The only points on the number line that stay the same when you square them are 0 and 1. So that's the big inference that we must make before we even read the question. Right? The free info here is telling us what? Either xy equals 1 or xy equals 0. That's the inference. And I think if we didn't make that inference early on, before reading the question, then we're off to a very bad start, and we're unlikely to be able to solve the question. Now, I've said many times that when a data sufficiency question offers you free info, that free info is the most important thing on the computer screen. And I made the analogy that in sentence correction, the non-underlined text is the most important thing on the computer screen. The non-underlined text in sentence correction is your free info. I'll put a link when this becomes a YouTube video to the video where I talk about that. You made a classic error there of accidentally assuming that they have to be integers. I used to make that classic error as well back in the day, and I noticed that I stopped making that error when I started using number lines religiously. Number lines are very continuous in nature. By the way, another classic error people make is they assume something has to be positive. That didn't happen to you here, but maybe it happens to you in other places. So again, drawing a lot of number lines as on a regular basis makes it a lot less likely that you'll make any of those bad assumptions, or something has to be positive or something has to be an integer, unless they told you that it's a positive integer. But otherwise, you wouldn't make that assumption if you're drawing a lot of number lines on a regular basis. At least that's how it worked for me. So I'm hoping that that will be true for you as well. A lot of number lines will prevent you from making such assumptions. Okay, so now we know that the product xy is either 1 or 0. Now let's read the question. The question wants to know, what is the value of x plus y? So we're looking for the sum of two unknowns, but we know that the product of those two unknowns is either 1 or 0, and we want to know their sum. I don't know which statement I would start with here. They seem kind of similar in terms of difficulty to evaluate. So let's just start with statement 1. Statement 1 gives me the value of -1/2. So I want to take that with me to the free info and ask myself, now that I know the value of x, now that I know that it's -1/2, what can I say about the value of y? And what I would say about the value of y, given that x is -1/2, is that y is either -2, that's y, is -2, or y is 0, given that x is -1/2. These are the options for y for statement 1. Statement 1, y is either -2 or 0, and we know that x is -1/2, and the question wanted to know the sum of x and y. These two options for y would lead us to different answers. If y is -2, then the sum is -2.5. If y is 0, the sum is -1/2. So can I answer this question definitively, knowing that x is -1/2? No. Let's eliminate the answer choices that claim that statement 1 is sufficient on its own, because it's not. Now we don't know statement 1 anymore, but we do know that y is not 0. So, knowing that y is not 0, what can I say about x? In this scenario where xy is 0, if y is not 0, x must be 0. And in the first scenario where xy is 1, what can we say about x? We know that y is not 0, and we know that the product... Hey, if the product of xy is 1, then of course y is not 0. So statement 2 doesn't actually add any value for this scenario, and we'll just say x is question mark. I can't say anything at all about x for statement 2. So that's statement 2. Either x is 0 and y is not 0, or x is whatever and y is not. So basically, the free info is totally useless in the context of statement 2. So let's eliminate b. Now, if we combine these statements, we can eliminate... So I'm going back to what I knew from statement 1. Statement 1 seemed like a much better statement. It had a lot more to offer us, right? So I'm going back to what I knew from statement 1, which was that y is either -2 or 0, but now I can say that it's not 0 thanks to statement 2. Statement 2 eliminates this possibility, leaving me with only one option, which is that x is -1/2 and y is -2. And now, yes, I can answer the question. I wouldn't actually answer it at the test center, but just for fun, the sum is -2.5. So we can answer the question definitively when we combine the statements, but not when we look at them individually. And therefore, the correct answer is C. I think there's an important takeaway here. If you've done a great job evaluating a statement on its own, and that statement proved quite useful, not useful enough to be sufficient on its own, but useful in that it narrowed down the field of possibilities very significantly to only 2 or 3 or 4 possibilities, then when you eventually combine the statements, go back to the work that you did for the statement that was useful in its own, and use that as your starting point. And that's exactly what I did here. I already had only 2 possibilities from statement 1. It was a very useful, not quite useful enough to be sufficient on its own, but a very useful statement nonetheless. It narrowed down from an infinite number of options to just 2 possibilities. So use that as your starting point when you're combining the statements and say, all right, I already know this. Now, how does statement 2, how does the other statement help me if at all. If it doesn't, then the answer is E. But if it does help me to narrow down the field of possibilities even further, if it eliminates all but one of the options, then the answer is C. So I think that's a takeaway, is use the work that you already did from the better statement, from the more useful statement, and then use that as a starting point for when you're combining the statements. Imagine that a question asks, what is the value of x? And statement 1 tells us that x is positive, and statement 2 tells us that x is less than negative 10. This is not possible. This would never happen on the GMAT, because if x is positive, how can it be less than negative 10? Think about the number line. X can't be at two different places at the same time. So if we simplified some inequalities and ended up with this, then we must have made a mistake. Let me put that another way. The information from statement 1 has to allow the information from statement 2 to be true, and vice versa. For example, x is greater than negative 10. Knowing what statement 1 told us, is it possible that statement 2 is telling the truth? Yeah, in fact, it's implied, right? If x is positive, of course it's greater than negative 10. Statement 2 doesn't actually add any value here. And does statement 2 allow for statement 1 to be telling the truth? Yeah, if x is greater than negative 10, it is possible that it's positive. So each statement has to allow for the other statement to be telling the truth. Otherwise, they're contradicting one another, meaning one of them is lying, and that doesn't happen on the GMAT, because the statements are always telling the truth. And in this case, the correct answer would have been E, because I don't know what the value of x is. But if I change it a bit and say, what is the value of x if x is a positive integer divisible by 5? And I'm going to change the second statement a little bit and say x is less than 10. Statement 2 is sufficient on its own. But statement 1 gives us an infinite number of possibilities. And an example from real life is I could tell you, one statement is I'm in Canada, and another statement is I'm in Toronto. Those are not contradicting statements. It's possible that they're both true. But if the question is, am I in Ontario, which is the province that includes Toronto, then knowing that I'm in Canada is not sufficient to answer the question. I don't know which province I'm in. Maybe I'm in Ontario, maybe I'm in British Columbia. But knowing that I'm in Toronto does allow us to answer the question definitively, because if I'm in Toronto, then yes, I must be in Ontario. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.